Hello everyone. I just wanted to show you one of my capstone projects this year. So this is a filament recycling machine that is going to recycle the 3D printed wasted PLA filaments, and it is gonna re-spool them and you can use them again. So this is really good for saving on the material costs as well as saving the planet from all of the plastic waste. So what you can see here is in the first part of the machine we have a shredder. This component right here, that is our shredder. You can see it from the top. Okay, so this is our mechanical shredder, and when the machine starts, you put your plastic waste like support brim or anything else, failed prints, into the shredder. It's gonna shred it, and the shreds will be inside this container for collection. Right, you see there is some left here at the bottom of it. Then you can take them and you're going to store them into these containers, these hoppers here, which if you can see from the top, there are 6 of them. And each one you are going to store a different color. Okay, and the colors are recognized automatically by this camera here on the top. So all of the colors available are going to be shown on this monitor. It's off right now, but I'll show you a demo later. So it is going to turn on and it is going to show you all of the different colors available, and you can choose which color you want to be spooled back, and or if you want to mix them together, right? And then these hoppers, each one, they have a stepper motor and they have a screw mechanism. Hopefully you can see it here in the top, and those are going to open the hopper, and then everything is going to come down to this mixing system here, which is going to, by the force of gravity actually, and some rods that are inside it, it is going to mix if it has to, and then send them down here. Let me show you from this view. Send them down here to this melting mechanism here, right? So here is the screw mechanism, and here you have the heat bands, 3 of them. So it is good. They're going to melt the plastic for you. Each one has a thermostat that is going to measure the temperature, and by the way, the temperatures are also going to be shown and controlled from this monitor or HMI. So when those are melted, then the screw mechanism is going to push them forward, and the 1.75 mil, which is the standard size, is going to get out of what? Out of the tip of this extruder. As you can see, that small hole is exactly 1.75. Then the spool comes here and passes through the sensor, and the sensor measures the diameter of the spool. And if the diameter is more than 1.75 significantly or considerably, then it is going to command this stepper motor on the back of the spooler to basically apply more tension so it can reduce the diameter, and vice versa. And we have also this stepper motor, which is the aligning mechanism. So this guy is going to move the spool left and right. So as this guy rotates, not all of the spool is wound on the same basically part of this plastic here, and it moves basically left and right. Okay, and we also have fan here to cool down the plastic, right? And we have the emergency stop here. We have a button on the back to turn everything on. It has its own power supply here on the back, as you can see. And it has these 2 boxes which are for electrical components. And these are our motors, one of them for the screw mechanism of the melting system, and the other one is the motor for what? Turning the shredder. So this is a complete system which is smart, and as I said, you have with the HMI the control over temperature, the control over the speed of the tensioner, the detection of the colors, And one of the things that you might say, well, why do you have several hoppers, is first of all, depending on what size of the spool you want. So this guy can do 1 kilogram, can do more than 1 kilogram. You have a different, you have a variable size knot, so you can have basically a much bigger spool here, up to 5 kilogram to be made. And then one of the things you typically do, you do not use pure plastic from the shredder only. You typically combine something called the virgin plastic that is basically going to improve the strength of the material. They are like pellets, and they can basically change the color a little bit. Let me show you that. So here is the pellets that I just told you. You see here. So these are the pellets, and they're transparent. So when you mix them with any other color, they are not going to change the color significantly. Make it probably a little bit shinier and brighter, but not too much. But since these are the plastic that has not been used, we call them virgin plastic. When you combine them with the shredded plastic, they can improve the mechanical strength significantly. In general, you cannot recycle PLA more than 3-4 times. After that, it is going to lose its mechanical properties significantly. So mixing with the unused plastic is a common thing in recycling PLA or other plastics. So this machine right now is designed for recycling PLA, but if you put enclosure on it, we can recycle ABS as well, and you can heat up the chamber here for higher temperature, so you can like recycle TPU and other plastics as well. But it has not really any limitation to PLA. As I said, you can do anything you want. And one last thing, this door here, it also has sensors. And if for any reason this door is opened during the operation of the shredder, as soon as the sensor activated, it is automatically going to stop the machine. So you cannot open this door when the shredder is working, to be safe, so nobody can poke their fingers into the machine. And as I said, we have emergency stop, and we have all sorts of signs here for the areas that your finger might be pinched, or these areas where your finger can be burned. So the safety is also extremely considered in this machine. And here is a small print. It's a small frog that is made from the recycled plastic here. So just wanted to show you one of my capstone projects, which I'm really proud of, and they did a very, very beautiful job this semester and last, and they made an entire machine with the cost of a little bit more than $2,000. If you look, commercial products for a recycler machine are typically around $14,000-15,000 and above, and most of them do not have HMI, they do not have several hoppers, they do not have any vision system. Most of them do not even have a shredder. They are mostly a melting mechanism and a winding mechanism. So this machine, at a cost of probably up to 8 to 10 times cheaper than them, can do a lot more than what they did. And this is what a real capstone is about: making a product that works and that solves a problem from the society, the market, or anything. And this machine, we're going to keep it in our rapid prototyping lab, and we're going to recycle our plastics from here. So hopefully this video was useful to you, and I will see you in my next video. Thank you.